The following are the learning objectives of this video presentation. At the end of this video presentation, you are expected to, number 1, demonstrate your understanding about a cubic function, an identity function, and an absolute value function. Second, set up table of values for each of these basic functions to accurately sketch the graph. This time, we are going to discuss about cubic function, and this is the fourth basic function in our general mathematics. Cubic function is a function whose graph is a curve with a point of symmetry. It is represented by the equation y is equal to a quantity x minus h quantity cube plus k, where h and k is the point of symmetry. The degree of a cubic function is 3. When we say degree of a function, it refers to the highest exponent of x. Therefore, the highest exponent of x is 3, then our degree is 3. Because if we are talking about function, we are always ensuring that the exponent of y is always 1. That is why, in looking for the degree of a function, we are always referring to the highest exponent of x. Set up table of values for each cubic function and sketch the graph. We will start with the most basic cubic function, which is y is equal to x cubed. We do not have a linear term. We do not have also a constant term. We have only the cubic term. If that is the case, our point of symmetry, which is the most important property or characteristic of a cubic function, is the origin. The same strategy we are going to apply with setting up table of values with that of the quadratic function. The most essential property of a quadratic function is the vertex. But in cubic function, the most important characteristic is the point of symmetry. That is why our points of symmetry must be put in the middle of the table of values. And we are going to arrange the values of x in increasing order, following, of course, the point of symmetry, in which if you're going to look for the preceding value of x, you're going to consider the abscissa of the point of symmetry. You have 0 minus 1 is negative 1. Then negative 1 minus 1 is negative 2. Then here, the values of x to the right of point of symmetry, just only add 1. So 0 plus 1 is 1. Then 1 plus 1 is 2. Therefore, our x values are already arranged in increasing order. Afterwards, we are going to solve for the value of y. If x is equal to negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Because exponent tells how many times the base is to multiply itself. Do not multiply the base and that of the exponent because that is very wrong. Now, if x is equal to negative 2, substitute negative 2 with x. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. You need to solve the values of y in the right side because it is not like with that of the quadratic function in which the image of the two symmetric points are equal. Here, the images are not equal. Look at this one. The images are not equal. So therefore, you are going to look the value of y in its given pre-image or the value of the domain or the element of the domain. If our x is equal to 1, 1 times 1 times 1 is 1. If x is equal to 2, 2 times 2 times 2 is 8. How are we going to sketch the graph of y is equal to x cubed? The first thing that we're going to do is to draw the Cartesian plane, of course. The y-axis After drawing the y-axis, you're going to draw the x-axis. Now, you're going to consider the table of values here so that you cannot have a quadrant in which it is not needed in your graph. Look at this. You need the positive x, you need also the negative x-axis, you need the negative y-axis, and you need also the positive y-axis. Therefore, this is our graph. We are going to plot the points, starting with the point of symmetry, the origin. This is it. Now, we are going to zoom this graph so that it is very visible to you. The graph is this one. If x is equal to 0, y is equal to 0. And that is our origin. If our x is negative 1, our y is negative 1. And that is found in the third quadrant. Negative 1, then negative 1. If x is negative 2, y is negative 8. Negative 1, negative 2, then move downward. 1, 2, 3, 4, 5, 6, 7, 8. And this is our point with coordinates negative 2 and negative 8. We will proceed with the right side of our table of values. If x is equal to 1, y is 1. So 1, then move upward 1 unit, and this is our point. If x is equal to 2, y is 8. So 1, 2, then move upward because your y is positive. 1, 2, 3, 4, 5, 6, 7, 8. This is the point with coordinates 2 and 8. Do not connect this curve with a line because line is only given by an equation with degree 1, meaning the highest exponent of x is 1. Therefore, if you're going to connect this by line, that is wrong. Do not connect, especially this one, do not connect this with a line because this is not a line, this is a curve with point of symmetry. What is the meaning of point of symmetry? These 2 points are symmetric with each other, but the symmetry is different from that of the axis of symmetry or the parabola, which is symmetric with the horizontal line. The 2 points are symmetric with each other. Start from this. Then draw a curve going down with very smooth curve until to this point. Do not connect this by a line but a curve, and up to this, then curve. Upon reaching point of symmetry, whatever the direction of the curve upward must be reflected here, downward, as you can see here. This is it. Then afterwards, you are going to specify of course, the point of symmetry. Our graph will be red mark. If you're going to do your assignment, the graph will be red mark so that it will be emphasized. This is the graph of y is equal to x cubed. We will proceed with number 2. Y is equal to negative quantity x plus 2 quantity cubed. What we are going to do here is to identify the point of symmetry. What do you think is the point of symmetry? Take note, our k here is 0. Therefore, our point of symmetry is along the x-axis. And that is x plus 2 is equal to 0. Solve for the value of x. X is equal to negative 2. And that is the abscissa of the point of symmetry. And this is it. And our k is equal to 0 because the given equation of the cubic function is equal to a quantity x plus h quantity cube plus k. Our k is 0, meaning our point of symmetry is along the x-axis because our ordinate is 0. Ordinate or image is equal to 0 or codomain. Another term for image is ordinate. Another term for ordinate or image is codomain. This is abscissa, x-coordinate, or pre-image. After that, the abscissa of the point of symmetry is negative 2. Therefore, negative 2 minus 1 is negative 3. Negative 3 minus 1 is negative 4. Here, negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. Then solve for the value of y. Do not start here because if you are familiar with the point of symmetry form of the cubic function, even though you will not substitute negative 2 in here, that is understood to be 0. But we are going to try. Negative 2 plus 2 is 0. 0 raised to 3 is 0. 0 times negative 1 is 0. We will proceed with negative 3. If x is equal to negative 3, negative 3 plus 2 is negative 1. Negative 1 raised to 3, negative 1 times negative 1, positive 1. Positive 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1 already. Meaning, you are going to substitute the given value of x and solve for the value of y. This is just only mental solution because this is basic, students. Now, if x is equal to negative 4, negative 4 plus 2 is negative 2. Negative 2 raised to 3 is negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times negative 1 is positive 8 already. If x is equal to negative 1, negative 1 plus 2 is 1. 1 raised to 3 is 1. 1 times negative 1 is negative 1. If x is equal to 0, 0 plus 2 is 2. 2 raised to 3 is positive 8. Positive 8 times negative 1 is negative 8. Therefore, we are going to sketch the graph in which we are going to just only have the quadrants which are necessary in our graph. Therefore, you're going to anticipate where are you going to draw your y-axis as well as the x-axis in order to anticipate that you don't need the positive x-axis because you do not have the positive x-axis here. Here is our graph. If you want to cut until here, that is still correct because we do not have a point here, but I just only put here to make the graph beautiful. If you're going to submit your graph, you're going to evaluate first yourself. Is my graph attractive already? Negative 2 and 0, where is that? Negative 1, negative 2, and this is the point of symmetry. It is not indicated here because there is no space. And we will proceed with negative 3 and 1. Where is that? Negative 3, this is it. 1, 2, 3, and positive 1, meaning 1, 2, 3, then move upward because your y is 1. If x is equal to negative 4, y is 8. Where is negative 4? 1, 2, 3, 4. Then move upward because your y is positive. 1, 2, 3, 4, 5, 6, 7, 8. This is the point with coordinates negative 4 and 8. If x is equal to negative 1, y is negative 1. Negative 1, then negative 1. These are the coordinates of this point, negative 1 and negative 1. Now, if x is equal to 0 and y is equal to negative 8, where is the point? X is 0, therefore, do not move to the right, do not move to the left, move downward automatically. 8 units. 1, 2, 3, 4, 5, 6, 7, 8. This is it. Take note, if our cubic term is negative, look at this style of the cubic function. Just a while ago, we have this particular form because our cubic term is positive. Now, if our cubic term is negative, like this one. If our A is positive, like this one. If our A is negative, like this graph given by example number 2. The point of symmetry is this point, and the coordinates are negative 2 and 0, and that is our point of symmetry. Now, we will proceed with the last example of our cubic function. Y is equal to quantity x minus 3, quantity cube minus 2. What are the coordinates of the point of symmetry? 3 and negative 2. Therefore, that will be put in the middle of our table of values. X is 3 and y is negative 2. Therefore, we are going to arrange the values of x. 3 minus 1 is 2. 2 minus 1 is 1. 3 plus 1 is 4. 4 plus 1 is 5. Then solve. If x is equal to 2, 2 minus 3 is negative 1. Negative 1 raised to 3 is negative 1. Negative 1 minus 2 is negative 3. That is correct. If x is equal to 1, 1 minus 3 is negative 2. Negative 2 raised to 3 is negative 8. Negative 8 minus 2 is negative 10. How did I get negative 8? 1 minus 3 is negative 2. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. If x is equal to 4, 4 minus 3, 1. 1 raised to 3 is 1. 1 minus 2 is negative 1. If x is equal to 5, 5 minus 3 is 2. 2 raised to 3 is 8. 8 minus 2 is 6. And this is the graph. So how are we going to plot the points? We will start from the point of symmetry. 3 and negative 2. 1, 2, 3. Then move downward. This is 3 and negative 2. Then if x is equal to 2, what is the value of y? Negative 3. 1, 2, then negative 3. Then 1, 2, 3. This is it. 2 and negative 3. If x is equal to 1, y is negative 10. 1. Then count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our point with coordinates 1 and negative 10. These 2 points are symmetric with each other. These 2 points are symmetric with each other. With respect to the point of symmetry, this is our point of symmetry. And if x is equal to 5, y is 6, 1, 2, 3, 4, 5. Then move upward, 1, 2, 3, 4, 5, 6. This is our point with coordinates 5 and 6. Our point of symmetry is 3 and negative 2. And this is the graph of y is equal to quantity x minus 3, quantity cube minus 2. Because same thing that you're going to do, connect it with a smooth curve going downward. That is our point of symmetry. Now, we will proceed with the identity function, and this is the second to the easiest function because we have only one example of this function. Identity function is a function whose graph is a straight line that passes through the origin and divides the Cartesian plane into 2 equal parts. It is denoted by the equation y is equal to x. It is a type of a linear function. Example, construct a table of values for the identity function y is equal to x. Then sketch the graph. We have only one example of identity function. If we are going to sketch the graph of a line, we need only 2 points. But in this particular linear function, which is identity function, I have here 5 points so that we can really understand how are we going to sketch the graph of the identity function. Then, you're going to arrange the values of x in increasing order. I start with negative 2, negative 1, 0, 1, 2. There is point of symmetry here. Whatever the value of x, that is also the value of y. Because y is equal to x. If x is equal to 0, y is equal to 0. If x is equal to negative 1, y is also negative 1. If x is equal to negative 2, y is also negative 2. If x is equal to 1, y is also 1. If x is equal to 2, y is also 2. Because y is equal to x. Now, this is the graph. This divides the Cartesian plane into two congruent parts. And it passes through the origin. Actually, these 2 points are just all symmetric with each other. And this also 2 points. And the point of symmetry is the origin. Okay, we will proceed with the last basic function in this video presentation, which is absolute value function. What do you mean by absolute value? What is the absolute value of negative 3? The absolute value of negative 3 is positive 3. What is the absolute value of 5? It is also 5. Because when we say absolute value, it refers to the distance between 2 points. There is no negative absolute value. The absolute value of a negative number is a positive. The absolute value of 0 is 0. The absolute value of positive is positive also. Meaning, there is no negative number that will be resulted from the given absolute value symbol. Absolute value of 6 is 6. Absolute value of negative 1.5 is positive 1.5. The absolute value of 1,000 is 1,000. The absolute value of negative 20 is positive 20. Absolute value function is a function that contains an algebraic expression within absolute value symbols. It is denoted by the equation y is equal to a absolute value of x minus h absolute value plus k. This is the symbol for absolute value. Wherein our h and k is the vertex. There is a vertex. And there is also the axis of symmetry. Take note, the graph of an absolute value function is not a curve. It is a graph of two intersecting lines in which these intersecting lines meet at the vertex with axis of symmetry. When you say axis of symmetry, a line which is perpendicular to the horizontal line, and that line divides the opening of the absolute value function into two congruent parts. Okay, let us have these examples. Construct table of values for each absolute value function. Then sketch the graph. Number 1. This is the very basic example of absolute value function. Y is equal to absolute value of x. The vertex of the absolute value function is the origin. Since that this is not a curve, you need only 3 points. The first point is the vertex because this is just only a line and this is another line. Since you are not graphing a curve, you need only 3 points. And the third point is the vertex. How are you going to sketch the graph of this? This is it. If x is equal to 0, absolute value of 0 is 0. That is the value of y. If x is negative 1, absolute value of negative 1 is 1. What is the meaning of absolute value of negative 1? That is the distance between 0 and negative 1 is 1. There is no negative distance. Therefore, there is no negative result for the absolute value. Any number here, either negative or positive, the result is positive. Absolute value of 0 is 0. If x is equal to 1, absolute value of 1 is 1. Therefore, this is very simple. The vertex is the origin. This is it. If x is equal to negative 1, y is positive 1. Negative 1. And this is positive 1. This is the point with coordinates negative 1 and 1. If x is equal to 1, our y is 1. This is our point. Then, connect these 2 points with a ray. Take note, do not extend like this one because this is not a part of our graph. There is no negative value of y. In this function, negative numbers not a part of the set of values of y. Therefore, do not extend the line here. This is array, meaning there is an origin or the endpoint. Then another ray there, and these two lines are reflections of each other because we have the so-called axis of symmetry, and this is it. We have also the vertex, and that is the origin, and this is the graph of y is equal to absolute value of x. We will proceed with number 2. Y is equal to negative absolute value of x plus 4. The vertex is negative 4 and 0. This is our vertex. Then don't forget to arrange the values of x in increasing order so that you can have the technique to sketch the graph of the absolute value. Now this is negative 4. How did you get negative 5? Negative 4 minus 1 is negative 5. How did you get negative 3? Negative 4 plus 1 is negative 3. How did you get negative 4? Because the abscissa of the vertex is here. X plus 4 is equal to 0. Solve for the value of x. X is equal to negative 4. And where did you get 0? Because your k here is 0. Or you're going to substitute. Negative 4 plus 4 is 0. Absolute value of 0 is 0. Now how about if x is equal to negative 5? Negative 5 plus 4 is negative 1. Absolute value of negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Take note, symmetric. When it says symmetric points, we have two different abscissas with one ordinate. Symmetric points are points with two different pre-images with the same image. Abscissa is also known as pre-image. Ordinate is also known as image. Two different abscissas with one ordinate are symmetric points. How are we going to sketch the graph? This is opening downward. Take note, the value of a signifies the opening of the absolute value function. Just a while ago, our a is positive, therefore the opening is upward. Today, our a is negative, therefore it is opening downward. Because there is no positive value of y will be coming out. Because this is negative. We're going to plot the points. Negative 4 and 0. Where is it? Take note, you do not need this quadrant. Also with this quadrant. Therefore, you are going to draw a Cartesian plane in which the quadrants are just only the quadrants needed in the certain graph. Like this one. And our graph is beautiful. 1, 2, 3, 4. This is negative 4 and 0. Take note, if our ordinate is 0, our point is along the x-axis. This point, negative 5 and negative 1. 1, 2, 3, 4, 5. We have here the negative 5 and move downward. And this is negative 5 and negative 1. Because it is in the third quadrant. If x is equal to negative 3, y is negative 1. So, 1, 2, 3, then move downward, and this is our point. Connect this by a ray. Do not extend your graph here as well as there because positive values are not part of the value of y. Because this absolute value symbol is preceded by negative. This is the graph of y is equal to negative absolute value of x plus 4. This is our axis of symmetry. Y-axis because that is parallel with the y-axis, passes through the vertex, and that divides the opening of the absolute value function graph into two congruent parts. This one. This area is congruent with this. We will proceed with the properties of absolute value function, which is the vertex, that is it, and the axis of symmetry, this is it. We will proceed with the last example of absolute value function. And we will not have first the assignment here because I'm going to give you the assignment after finishing discussing the concept of basic functions and their graphs. Number 3, y is equal to 2 absolute value of x minus 3 absolute value minus 4. What is the vertex? 3 and negative 4. Therefore, that must be put in the center. Take note, if you're going to graph absolute value function, you don't need 5 points. 3 points only because this is a line, this is also a line, or ray. Take note, ray is a kind of a line. Half line is a kind of a ray. Therefore, half line is also a line. The vertex is this point with coordinates 3 and negative 4. Where did you get 3? Here. Where did you get negative 4? There. Take note, how did you get positive 3? X minus 3 is equal to 0. So for the value of x, x is equal to 3. And we are going to check if this will be coming out for your y. 3 minus 3 is 0. Absolute value of 0 is 0. Times 2 is 0. Minus 4 is negative 4. Since that this is 3, to the right of 3 is 4. If x is equal to 2, 2 minus 3 is negative 1. Absolute value of negative 1 is positive 1. Positive 1 times 2 is 2. 2 minus 4 is negative 2. It is mental solution only because this is very simple. If x equal to 4, 4 minus 3 is 1. Absolute value of 1 is 1. 1 times 2 is 2. 2 minus 4 is negative 2. And this is the graph. Take note, you are going to plot the vertex first. 3 and negative 4. 1, 2, 3. Then 1, 2, 3, 4. This is a 3 and negative 4. And this point, 2 and negative 2. 1, 2, positive x. And negative y. This is it. And the coordinates are 2 and negative 2. We have the point here 4 and negative 2. 1, 2, 3, 4. And going downward, which is negative 2. Take note, you don't need actually the second and the third quadrant. Do not extend your x-axis here anymore because that is awkward to see. You have a very long line here, but there is no graph. This is our axis of symmetry. And we are going to have the properties, vertex, then the axis of symmetry is. That ends our lesson in this video presentation. So there are already 6 basic functions that we have already discussed. And the last one is the piecewise function, and that is more complex. And we will discuss that lesson in the next video presentation together with the real-life situations represented by functions. How are we going to represent real-life situations using functions? And how are we going to solve problems that will apply the concept of functions? Thank you very much for watching this video.